In this video lecture, we're going to go through a short recap of what we've previously learned about classes in Java before we start to write our own user classes. Okay, let's get started. It's been several weeks now since we first talked about classes and objects in Java. Since then, we've completed program assignments in which we've used pre-built classes such as CS12Date, Scanner, String, Math, and a handful of others. By now, hopefully you've gotten a tangible sense of what classes and objects are all about, and their usefulness in writing new programs. Now, over the coming lecture materials for the next 2 weeks or so, we're going to get to what I think is the real fun part of Java, and that's creating our own user classes. This is also the point where everything we've learned about the language so far gets tied together, so to speak, into reusable, self-contained software components of our own design. This, then, is the real heart of working in any object-oriented programming language. If classes and objects are still a little hazy for you, you might want to go back now and review the prior materials on using classes in Java. But just as a refresher, here's a quick summary of that prior lecture material. Above all, we said that a class is the blueprint or template for some kind of software thing. Classes are simply software models of some kind of real-world entities. If classes are the general descriptions, then objects are the specific instances of them. We made an earlier analogy of a class being a cookie cutter versus an object being any one specific cookie created from that cookie cutter. At this point in my on-ground classes, I drive this point home with some sort of cookie-based demo, but online, well, you just need to do that demo in your head. On a basic level, everything, and I mean everything in Java, is ultimately a class. Programs we write in Java are themselves actually Java classes. If you think about it, every program you've written so far this semester has begun with the words public class, name of class, or a class itself. Inside those classes, we've in turn made use of other classes such as CS12Date, String, or Scanner. The advantages of this class-based organization in object-oriented programming are these. Classes bundle together or encapsulate some set of data together with all the possible operations upon that data or its methods. All of the implementation details are buried away, and we can use a well-written class over and over again simply according to its API description. All of this leads us towards software development efficiency, or the old paradigm about not reinventing the wheel. We don't have to know all the internal details of String, Scanner, or any other Java class in order to simply use it. However, now we are setting ourselves up to cross over to the other side and begin writing our own classes. So now, yes, we will need to begin to understand what lies under the hood. But at this point, we have all the fundamentals of Java under our belts to do so. If we wanted to classify the types of classes available to us in Java, we'd probably come up with something along these lines. In a very general sense, we have two basic types of classes: predefined classes and user-defined classes. Predefined classes are those which are automatically available to us when we install the Java JDK, and there are roughly 2,000 or more of these, all described for us online in the Java API. Some of these classes are automatically available for us to use, with no action needed upon our part. These might be classes such as String or Math, which live in the java.lang package and require no import, so we can use these immediately. By contrast, most classes must be imported before they can be used, as we've seen with Scanner, JOptionPane, Random, and others. In addition, while most classes are object-based, such as these ones in blue, other classes might be invoked statically, such as these ones in green. The difference here is that most classes require objects to be instantiated first, such as String or Scanner objects, before we can call their API methods. But other classes are called statically, which simply means their methods are called directly using the name of the class, such as we've seen for Math or JOptionPane. In contrast, user-defined classes allow programmers to extend the core Java language with their own capabilities. Examples of these are all the code you've written so far in this course. Every one of my lecture source code examples, such as CS12Date, all the examples in the textbook, and any third-party software we might download or install. User-defined classes let us tailor the language to suit our own specific needs and purposes, and this is the direction we'll be going in the coming lecture materials. Going back over some basic class terminology. The members of the class are the combination of its fields or instance variables and its methods. Instance variables are simply the data of some class, and its methods are all the operations we can perform upon that data. An object is simply one specific named instance of some class. For example, if we were considering CS12date as the class, then Thanksgiving would be one specific object of the CS12date class. Again, classes are the general and objects are the specific. A client is some outside piece of code which uses an object of some particular class type. For example, we've used the scanner class quite a bit to obtain user input for our programs. Each one of those homework programs you've written has been a client of the scanner class. Also, as we go forward with writing our own classes, clients will also represent the test driver code we write to test out our new classes. An access specifier is simply a Java keyword which establishes the visibility of some class, or any of its data or methods, to the outside world. In other words, can or cannot the outside world see and use the methods and data of a class. Access specifiers may be public, private, or protected, but in this course we will only consider the public and private access specifiers. Finally, scope refers to the range over which variables or methods can be seen and used inside their own class. We'll get to all of these very soon as we start to write our own classes, but they're listed here just so we can define our terms. The diagram shown here on the right shows the general structure of some generic Java class. In very broad terms, a class in Java consists of some relatively small handful of data, shown at the top here in red, and then a whole series of methods, shown in blue, which all operate upon that data. The big idea here is that the scope of this data is global throughout the entire class. In other words, this data is visible and accessible to every single method inside this class, whether that data is public or private. Furthermore, all of these methods share one common copy of the same data, and any changes to the data are instantly visible to all other methods. Even better, this data can be used by any one of these methods without having to additionally declare it, and it doesn't have to be passed into or out of any method using its calling interface. All of this data is simply usable by any of these methods with no development effort required on our part. In general, global data such as this is generally hugely frowned upon in programming because it leaves such data open to random, haphazard manipulation from any direction. However, global data is a whole lot easier to work with because you don't have to contend with passing it around using any method calls or interfaces. So in a sense, I suppose this represents a reasonable middle ground compromise. This data is global within the confines of this class, but it is hidden from usage by the wider outside world, as it properly should be. This is yet another beauty of object-oriented programming. Along similar lines, here on the right is the same diagram showing the general structure of some generic Java class. Now the focus is upon the scope of the methods of this class. Every method in this class can call or use any other method within the same class, whether those methods are declared public or private. Furthermore, the methods designated with a public access specifier can also be called by outside client programs. And these are the types of methods which we see listed in the API of a class, or which we've been using with dot notation upon objects of the string, scanner, CS12date, or any other class type. However, methods designated with a private access specifier cannot be seen or used by the outside world. Once again, generally speaking, a class is fundamentally a collection of some data together with lots of small individual possible operations upon that data via its available public API methods. So as we begin to design our own class in the coming lecture materials, this diagram is going to represent our approach or roadmap. First, we're going to outline or pseudocode all of these desired methods. Then we're going to gradually write them one by one in an incremental build a little, test a little approach. Let's start moving in that direction in the next lecture video.